My dear students, today I am going to discuss geometry for class 9, the chapter of lines and angles. So in my previous video, some days ago, I discussed theorems of geometry. Now how you can use those theorems, knowledge of those theorems in answering some questions. I mean to find some solution or to prove certain things, all right? Now let us see some questions. Suppose this is a question. When two straight lines intersect, the bisector of an angle, bisector of a pair of vertically opposite angles, bisectors of a pair of vertically opposite angles form a straight line. Now suppose this question is given to prove that when two straight lines intersect, the bisectors of a pair of vertically opposite angles form a straight line. Now when you get question like this in exam, first of all you have to draw a diagram. You have to find out what things given and what to prove. Now if you see here what is given, two straight lines are given which intersect. So you will draw two straight lines like this which intersect. Suppose AB and CD. Alright. So what is given? AB and CD are intersecting straight lines. So AB and CD intersect at suppose O. So this is a point O. So this is given when two straight lines intersect. So these are the two straight lines AB and CD which intersect at O. Alright. Then you have to prove the second part, what bisectors of a pair of vertically opposite angles form a straight line. So bisectors given, suppose we consider this pair of vertically opposite angles. So this is the bisector of this angle and this is the bisector of this angle. Suppose bisector given PO and QO. So this also given, PO is bisector of which angle? AOD, bisector of angle AOD, all right. And QO is bisector of angle what? COB. So all these things given. Okay. So pair of straight line intersecting given, but these two are vertically opposite angles. Their bisectors are given. Now what to prove? So to prove what? To prove these two bisectors form a straight line. That means PO and QO lie in a straight line. So this is what you have to prove. This PO and QO, they form a straight line. That means they lie in a straight line or they form a straight line. So this is how you write. So you read the question carefully. From the question, find out what things are given. So write properly given and then what to prove. Now in the exam, if you can do up to here correctly, then some step marking will be given, even if you do not do the proof. After this, we will come to construction and proof. But if you can draw the diagram correctly and write what is given and what to prove correctly, then you can expect some mark, some step marking, okay? All right, so now let us go to the proof, okay? So I am trying to show you how you think, how you have to think, how you have to write. Okay, so learn the method. Now we come to the proof. Now for some geometry questions like this, you need to do construction, but for this one no construction necessary. So we'll go directly to the proof. All right. Now see what is given. So PO is bisector of AOD. Therefore, these two angles are equal. Which two angles are equal? AOP and DOP. Suppose we call them X and X. Now, again, QO is bisector given. QO is the bisector of COB. Again, these two angles are equal. So let us see. Let us call this one Y. This is Y. So this angle is X. This angle is X. Why they are same? Because this is bisector. This angle is Y, this angle is Y. Why? They are bisectors. Now, if you write XY like this, then writing becomes easy. To make the writing easy, we use like that. Okay. So, proof, since PO is bisector of PO is bisector of AOD. Bisector of AOD. Now, for every geometric statement in the proof, you have to give reason. Now, why this PO is bisector of AOD? Because it is given. So, within bracket, you have to give the reason given. Now, if you do not give the reason for a statement, then some mark may be deducted in the end. You follow? Achha. Bisector. Therefore, those two angles are equal. Which two angles are equal? AOP, angle AOP equal to angle DOP. Angle AOP equal to angle DOP. Now, for convenience, we have called these two angles what? X. So, say means suppose. All right. Okay. Now, similarly, again what? Again, QO is bisector of COB. Again, QO is bisector of what? QO is bisector of what? COB. Angle COB, isn't it? Bisector of angle AOD, angle sine. So COB. Now this is given. All right. Therefore, what do you get? These two angles equal. Which two angles equal? COQ. This angle is equal to COQ is equal to what? COQ is equal to which angle? BOQ. Angle BOQ. Now suppose we call it Y. So each angle we are calling Y because they are equal. So say. So say means suppose. All right. Okay. So up to here I hope clear. So these two angles we are calling XX and these two angles we are calling YY. Now see what we have to prove. We have to prove PO and QO lie in a straight line. That means we have to prove POQ is a straight line. POQ is a straight line. This is what we have to prove. So we have to prove this POQ is a straight line. Now, if it is a straight line, then this angle on POQ will be a straight angle, because any angle on a straight line is what? Straight angle. Now, if we can prove this angle POQ, if we can prove this angle 180 degree. Which angle? This angle. This angle means POQ. If we can prove POQ equal to 180 degree, then we can say POQ is a straight line. You follow? So that is what we are going to do. Now this angle, if you see, it is a sum of this angle plus this angle plus this angle. That means now we have to prove sum of these three 180 degree. Okay. All right. So we got this one. Up to here I hope clear. Now again, for convenience of writing, so let us call these two angles, let us say these two angles MM. So this is O, this point is O. Now suppose we call this one angle M, this one angle M. Now angle AOC is equal to angle DOB. What reason? Vertically opposite angle. In the exam you write fully vertically opposite angle. Now these two angles are equal. Why? They are vertically opposite angle. So suppose you call M. See. So this X, Y, M, this type of writing helps in the writing. It simplifies the writing for convenience. Okay. Now you see the whole angle 360 degree. The complete angle, the whole angle around a point. This is a point O. So around O, the whole angle is 360 degree. Okay. Now the whole angle means what? See, x plus x, x plus x, plus m plus m plus y plus m. See, 1, 2, 3, 4, 5, 6. There are 6 angles. So sum of these 6 angles is 360 degree. X plus m plus y, 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 y plus m plus x, y plus m plus x. So this is equal to what? 360 degree. All right, 1, 2, 3, 4, 5, 6. Sum of these 6 angles equal to 360 degree. 360 degree. Now you see x plus x twice x, m plus m twice m, y plus y twice y. So that is equal to 360 degree. So this gives 2 common, x plus m plus y equal to 360 degree. Therefore, finally what you get? X plus m plus m, x plus m plus y equal to 360 by 2, that is 180 degree. So what we have got? X plus m plus y, these 3 together 180 degree. That is which angle? Angle POQ. So angle POQ equal to, we have got 180 degrees. See. So we have proved POQ 180 degrees. So therefore POQ is a straight line. So therefore POQ is a straight line. So proved. See. So POQ, this angle we have proved, this angle POQ, we have proved what? 180 degree. Therefore this is a straight line. That means PO and OQ lie in the same line. So this is how you will handle these kind of questions. This type of questions are called rider. So we have to use the knowledge of theorems. So we have used the knowledge of this theorem, vertically opposite angles are equal. Then we have used the knowledge of linear pair, or linear pair means here no linear pair but the straight angle. So there are 3 angles, we cannot call linear pair, but this straight angle is 180 degree. Then we have used the knowledge of that fact or statement, that is any angle around a point is 360 degree. Okay. So this is how you have to try to answer questions. All right. Okay, now let us see another. Now this first one I did in details, but for the others, so I'll do little briefly. Okay. Yes, now this is second question. Second question is this one. Now these are 2 vertically opposite angles. Suppose AB and CD. AB and CD intersect at O. All right. Now this is the bisector of so AB and CD are 2 intersecting line. Now this one is a bisector of, this is a bisector of, suppose this is the bisector of, suppose PO. This point is O. PO is a bisector of AOD. All right. Now we have to prove when PO is extended to Q. So OQ is a bisector of COB. So that is a question. So in the question, what is given? AB and CD are two intersecting straight line. They intersect at O. All these things you have to write as given. So what is given? AB and CD are two intersecting straight line. They are intersecting at O. PO is the bisector of angle AOD. PO is the bisector of angle AOD. Now PO is extended to Q. This is a straight line. PO is extended to Q. So required to prove OQ is a bisector of COB. So this is what you have to prove. To prove what? To prove OQ bisects COB, angle COB. So this is what you have to prove. So I repeat, AB and CD are intersecting at O, that is given. PO is bisector of AOD, that is given. So you have to prove OQ is bisector of COB. OQ bisects COB. All right. Now this is bisector of this given. So let us call it X and X for convenience of writing. So we are calling AOP equal to X, DOP equal to X. All right. So AOP equal to X. So now the proof. Now those given things, given required to prove those things, you have understood how to write. So that I am not repeating. I am showing the proof clearly. Okay. So you see, since PO is the bisector of, PO bisects angle AOD. So this is given. So within bracket you must write given. All right. Therefore, this AOP angle equal to which one? AOP equal to angle DOP. And suppose that is equal to X, say. All right. Suppose this X, suppose say. So this point is D. So these two angles we have taken XX. Okay. All right. Now see. Now this is a straight line. This is a straight line. Therefore, these two vertically opposite angles must be equal. All right. Since PQ and CD. Now PQ is a straight line, that is given. All right. Then CD is straight line. So since PQ and CD intersect, they intersect at O. Therefore, these two are equal vertically opposite angles, that is POD, angle POD. Angle POD equal to angle what? COQ. Angle COQ. What is the reason? Vertically opposite angle. So you see, since PQ and CD intersect at O, PQ and CD intersected at O, therefore these two angles are equal. POD and COQ are equal. Why? Vertically opposite angles. So suppose now we call them, now you see, so POD equal to COQ. Now POD is what? X. POD is X. So COQ will be X. So therefore COQ equal to X. So POD equal to X. So therefore COQ will be X. So this will be equal to X. All right. Similarly, you see, these two straight lines AB and PQ intersect at O. AB and PQ intersect at O. So AB and PQ intersect at O. Again AB and PQ intersect at O. And that is given. So you write in the exam given. All right. So in the exam you have to write given. So this point is P. So AB and PQ intersect at O. Therefore these two are vertically opposite angles equal. Therefore AOP angle equal to what? AOP equal to BOQ. Why? Vertically opposite angle. All right. Now AOP is x, therefore BOQ will be x, therefore BOQ equal to x. So we have got, you see, BOQ equal to x, and then we have got COQ equal to x. So these two equal. See, this is x, this is x. So BOQ equal to x, then COQ equal to x. Therefore these two are equal. So therefore what? BOQ equal to COQ. Therefore BOQ equal to COQ. All right. So therefore this BOQ equal to COQ. So these two angles are equal. Why? Both of them x each, isn't it? Therefore OQ is a bisector of COB. So therefore OQ is a bisector of, so OQ bisects what? OQ bisects COB, angle COB, proved. So you had to prove this, OQ is a bisector of COB. So OQ is a bisector of COB, bisection. Okay. So again you see, you have used the knowledge of vertically opposite angles, then you have used the knowledge of this, yes, that only here. Okay. All right. So yes, next let us see this one. There are a large number of geometry riders like these questions. So some of are very common in exams. So I have selected these questions which I find frequently come in exams. Okay. Yes. Now this one. So this is a straight line. This is a straight line. Suppose AB. AB is a straight line. All right. Then so another stands, CD stands on it. So AB is a straight line, CD stands on it. So these two are linear pair, isn't it? Now bisector of these two angles given. So DP is the bisector of CDB. DP bisects CDB, and then DQ bisects ADC. So what is given? CD stands on AB. Therefore these two are linear pair. Which two linear pair? CDA and CDB. These two are linear pair. Now it is given this DP is the bisector of CDB. So DP bisects CDB. That means these two angles are equal. Again it is given QD bisects CDA. So these two angles are given. So you have to prove this QDP. So to prove what? To prove this QDP is 90 degree. QDP equal to 90 degree. This is what you have to prove. So this angle QDP 90 degree you have to prove. Okay. So given to prove that part you know. Now the proof. Let us see the proof. Now DP is bisector of CDB. Therefore these two angles are equal. So again for convenience let us say this is x, this is x. All right. Since DP bisects angle CDB. Now this is given. So within bracket you will have to give the reason, isn't it? So therefore which two angles are equal? So DP bisects CDB. Therefore CDP this angle equal to which angle? CDP equal to BDP. And suppose each equal to x. Suppose say. So these two are, we have assumed x. Again this is bisector of this angle. That means these two angles are equal. So here these two angles are equal, and here these two angles are equal. Suppose we call them YY. All right. So similarly, what you get? Similarly, what we get? These two angles. So QDA, QD QDA, this angle is equal to what? QDA equal to QDC. QDC. Why? Because this is bisector. All those details you will write. So I have written briefly. So this is bisector of this angle. Therefore, these two are equal. So let us say y each. So y say. All right. So this is x, this is y, y. Now the whole angle is 180-degree linear pair because this was the line. This was the line standing on this. So these two are linear pair. This one and this one. This angle and this angle linear pair. So their sum is 180-degree, isn't it? That means sum of all the four equal to 180-degree, isn't it? Now we know sum of all the angles. That means y, y, x, x. So y plus x equal to 180-degree. You can call it straight angle also here. If you do not use the knowledge of linear pair, then use the concept of straight angle, because this is a straight line. Any angle on straight line is what? Straight angle, isn't it? Straight angle. So this plus this plus this plus this. So y plus x plus equal 180-degree. So here we get 2x plus y. 2x plus y equal to 180-degree, isn't it? So therefore x plus y. Therefore x plus y equal to what? 90-degree. So we have got x plus y 90-degree. X plus y means which one? This angle. You see this angle. So we have got x plus y 90-degree. Now x plus y 90-degree. X plus y means QDP. So that gives us what? That gives us angle QDP equal to 90-degree. So this is what we had to prove. You see, to prove this one. So we had to prove QDP equal to 90. So we got QDP equal to 90. So x plus y equal to 90 we have got. Now x plus y means this angle. This angle is QDP, that is 90 degrees. So proved. So you see, this is how we have to do. So here we have used the knowledge of what? Straight angle. Straight angle or linear pair you can use. Okay. All right. Okay, now let us see the next one. Now this one is quite common in exam. So this next question that we are going to do, quite common in exam. So this is a thing. So this is a triangle and this is produce external angle. So ABC is a triangle, BC is produced to suppose D. Then you get this external angle ACD, all right? Then the bisector given ACD, bisector of this angle given B, this angle bisector and this angle bisector. So two bisectors are given, BP. So BP is a bisector of this angle ABC and CP is a bisector of ACD, and these two bisectors meet at P. So you have to prove to prove this angle P equal to half of A. So that means angle A by 2. This is what you have to prove. To prove this angle is half of this angle. So angle P equal to half of A. So what is given? This is bisector of this angle given. So we can call it XX. Then this is bisector of this given. So we can call it YY. So that makes writing easier. If you use that letter X, Y and all, writing becomes easy. All right. So what is given? Again, let me repeat. ABC is a triangle given. BC is extended to D. Therefore, ACD is the external angle. All this is you will write in the given thing. BP is bisector of angle B, that is given. CP is bisector of angle ACD, that is given. So all these things you have to write under the heading given. Then to prove this one. Now come to the proof. Okay, proof. All right. Yes. Now see. Now we have to prove this. We have to prove p equal to a by 2. That means a equal to twice p. You can think any other way. All right. Okay. Now we can start from p or start from a. So let me start from a. So we have to prove p equal to a by 2. That means we have to prove a equal to twice p. So let us start from a. Okay. Now angle A is equal to, you see, ACD minus angle ABC. Yes, that in my last video I showed this one, the theorem. So you see, this is a triangle, then this is the external angle. Now this external angle equal to sum of these two. So that was the theorem we discussed. I discussed in my previous video. So this is a triangle. This line is produced, so we get this external angle. The external angle is equal to sum of two opposite angles. So this angle is equal to this plus this. Now you see this angle ACD is equal to what? A plus B. So this is A, B, C, D. So this ACD equal to A plus B. If ACD equal to A plus B, what will be A? ACD minus B. That is what I am writing here, ACD minus B. This angle equal to this plus this. External angle equal to sum of opposite internal angle. Sum of opposite internal angles. This equal to this plus this. Therefore, this minus this will be A. So what will be A? This minus this. So angle A equal to this minus this. So this angle minus this angle. Okay. So all the knowledge of all the theorems you must have clearly. Okay. Now ACD. Now ACD is twice x. See, this angle ACD is x plus x twice x because that was the bisector, isn't it? ABC is twice y. ABC is this one, y plus y twice y, isn't it? So if you take 2 common, what we get? X minus y. So angle A is equal to what we got? X minus y. Now we have to get angle A equal to twice p. We have to get angle A equal to twice p, but angle A equal to, we got twice x minus y. That means this x minus y is p. But why it is p? Let us see. Okay. Now look at this side, this triangle BCP. Look at this triangle BCP. BC, this is P. Look at this triangle BPC. This is BPC. This is D. Okay, look at this BPCD. BPCD. Now this angle which is x, PCD is x, you see. Now that is equal to this plus this. So external angle, like before, external angle is equal to sum of opposite internal angles. So x equal to what? P plus B. Now B is what? Y. This angle is y. So x equal to what? This angle equal to this plus this. Therefore, what will be this minus this angle P? So what will be x minus y? X minus y will be angle P, isn't it? So here 2 into x minus y. Now x is what? PCD. X is PCD. And y is what? PBC. PBC. So PCD minus PBC. PCD, this angle minus PBC, this angle. This is sum of these two. This is sum of this and this. Therefore, this minus this will be what? Angle P. So that will be angle P. So we have got what? Angle A equal to twice P. So we have got A equal to twice P. Now what was to prove? What was to prove? P equal to half of A. So that gives P equal to half of A. So A by 2. So proved. So P equal to A by 2, proved. So you see, we have used here which knowledge? External angle is equal to sum of opposite internal angle. So that is a very important theorem. So that knowledge we have used. Okay. So as I told you, this is very common in exam. All right. Now I have written only briefly, but you try to write at home properly, giving proper reason and all that. So after understanding how to find it, so it will not be difficult to write. Now in exam, what you do when you get a question, try to get the answer roughly. Without getting the whole answer roughly, do not start writing, because then it will be aimlessly going. There will be no end to it. Then in the middle somewhere you have to leave it. So time will be wasted. So when you get any question like that, proof, riders, these are called riders. So you find the answer roughly. Try to get the whole answer roughly. Then only you start writing. Is it clear? Without getting the answer, if you start writing, then you'll be lost in the middle and you'll have to give up and all the time will be wasted. Okay, now coming to the next question. Coming to the next question. Yeah, this is also quite common in exam. This is a right angle triangle. ABC is a right angle triangle. So angle B is 90 degree. Then from B a perpendicular is drawn, BD. Perpendicular, therefore these are 90 degree angles. So ABC is a right angle given. So from the question, that is what you understand. Given what? ABC is a right angle triangle. Angle B 90 degree. From B a perpendicular is drawn to AC. BD is drawn perpendicular to AC. All these things are given. So this is 90 degree, this is 90 degree, this is 90 degree. All these things are given. Okay. Now required to prove what? To prove this angle is equal to this angle. That means angle A. Angle A is equal to angle this, that is DBC. DBC. And then angle C. You have to prove two things. Angle C equal to this angle. That means ABD. ABD. So what is given? ABC is a right angle triangle. Angle B 90 degree. From B, BD is dropped perpendicular to AC. Therefore, these two are 90 degree angles. All this is given. Required to prove this angle equal to this angle and this angle equal to this angle. All right. Angle A equal to DBC. Angle C equal to ABD. Okay. Now the proof. Now let us see the proof. All right. Now we have to use that theorem, angle sum property. Sum of three angles of a triangle 180 degree, isn't it? Now in a right angle triangle, you see, if this is 90 degree, then sum of the other two must be 90 degree. In a triangle, if one angle alone is 90 degree, then the sum of the other two must be 90 degree. That means the sum of the acute angles of a right angle triangle is 90 degree. That is another derivation from the theorem. In a right angle triangle, one angle is 90 degree, the other two are obviously acute angles and their sum must be 90 degree. Now if you say this one, if you say this right angle triangle, so in the triangle ADB, which is ADB, this is a right angle triangle, this is 90 degree. Therefore, this plus this, this plus this what? 90 degree. So, this is 90 degree, therefore, A plus B, that means angle A plus angle ABD, equal to 90 degree, isn't it? So, this triangle, in this triangle ADB, this angle alone is 90, therefore, this plus this will be 90 degree. Okay. Therefore, angle A is what? 90 degree minus ABD, So 90 degree minus ABD. Okay. Okay, you keep it as 1. Sometimes you write like that, like in equation 1 and 2. So angle A equal to, we have got 90 minus ABD. Again you see, now this angle is 90 degree, angle ABC is 90 degree. ABC means this plus this, so this plus this 90 degree. Again ABD plus DBC, again ABD plus DBC equal to 90 degree, isn't it? This angle 90 degree given, so this plus this 90 degree, all right. Therefore, what you get DBC, what you get DBC, therefore DBC, therefore DBC equal to, DBC will be equal to 90 minus ABD, 90 degree minus ABD. So this one you call, suppose, number 2. Now compare these two statements, 90 minus ABD, 90 minus ABD. So A equal to 90 minus ABD, DBC equal to 90 minus ABD. So from 1 and 2 we get, that is how you write. So from 1 and 2 we get what? A equal to. So therefore from 1 and 2 we get A equal to DBC. A equal to DBC proved. So A equal to 90 minus ABD, DBC equal to 90 minus ABD. Therefore from 1 and 2 what we conclude? A equal to DBC. A equal to DBC. So this one we have got, A equal to DBC, right? Similarly, we can get the other. Okay, similarly C equal to ABD we can get, right? Yeah, so to get C equal to C equal to what, this one, again you see briefly. So similarly C equal to 90 minus DBC. So angle C equal to 90 minus, C will be 90 minus this right angle triangle, 90 minus DBC, 90 minus DBC, all right. Now C equal to 90 minus DBC. Now this angle, this plus this equal to 90. Therefore what will be 90 minus DBC? ABD, ABD. So C equal to ABD. So C equal to, now C plus this equal to 90. Therefore C equal to 90 minus this, 90 minus DBC. Now this plus this equal to 90. Therefore what will be this angle? 90 minus DBC, that means ABD. So therefore C equal to ABD. C equal to ABD proved. So the first one we have done in details, but the second one you can do a bit briefly. Okay. So you see, this is another common question in exam, all right. But there are thousands of writers like this. There are limited number of theorems, but thousands of this type of questions. So learn how to do it, learn the method. Okay, now coming to this one, next this one. Yes, now this is a triangle. This is a triangle. ABC is a triangle. BC is produced to D. AB is produced to D. BC is produced to E. And CA is produced to F. So ABC is a triangle. ABC is a triangle. ABC is a triangle. BC is produced to E. AB is produced to D. And CA is produced to F. Now we get three external angle. This is one external angle, ACE. This is another external angle, BAF. And this is a third external angle. This is a third external angle, CBD. So these three are external angle. Okay. Now you have to prove this sum of these three external angle. That means ACE plus ACE plus BAF, ACE this angle, BAF this angle, and then CBD plus CBD. So these three equal to 360 degree to prove. So this plus this plus this, sum of three external angles equal to 360 degree you have to prove. So what is given? This is a triangle given. BC is produced to E, so this is external angle. AB is produced to D, this is external angle. CA is produced to F, this is external angle. You have to prove sum of these three external angles, ACE, then BAF and CBD. Sum of these three equal to 360 degree. All right. Now we will use that theorem, external angle equal to sum of the opposite internal angles. So this angle is equal to sum of these three. So now the proof. So proof now, this angle BAF, that means the external angle at A, BAF, the external angle at A. At A there are two angles, internal, external. At each point there are two angles, internal, external, internal, external, internal, external. At this point the external angle BAF is equal to what? Sum of these two, sum of C and B. So sum of angle ACB and ABC. So this external angle equal to sum of these two internal angles. That theorem. Okay. Then at B, CBD. So CBD equal to which two? Which plus which? Now this angle is equal to this plus this. So this angle plus this angle. That means angle A plus angle C. That is angle BAC plus ACB. All right. Then lastly this angle ACE, external angle ACE. So this is equal to sum of which two internal angles? This angle will be this plus this, A plus B. That means BAC plus ABC. All right. So when you write in exam, you have to write external angle, and this side you have to give the region together. All right, give the region together. What region? External angle is equal to sum of the opposite internal angles. You can give the region together. External angle equal to sum of two opposite internal angles. Okay. All right. Now we have to show what's there. Sum is 360. Now add. You can draw a line, add. So this plus this plus this. So BAF. So BAF plus CBD plus ACE. So BAF plus CBD plus ACE. BAF plus CBD plus ACE. So that is equal to, yeah. So what we get, you see, ABC. So twice ABC. So when you are adding this plus this equal to sum of these six angles. Now ABC same, so twice ABC. Plus BAC same, twice BAC. Plus, yes, ACB same, twice ACB. Okay, now take 2 common. What do you get? ABC plus BAC plus ACB. So if you take 2 common, you get these three. Now these three together, 180 degree angle sum property. In the triangle, sum of these three angles, ABC, BAC and ACB, 180 degree. So 2 into 180 degree, isn't it? So 2 into 180 degree equal to, so last part equal to what? 2 into, this is 180 degree angle sum property. So therefore 360 degree. 360 degree, you see, this proved. Sum of this plus this plus this plus this plus this, you will write properly. So proved 360 degree. All right. So later on you will find in case of quadrilateral, pentagon, hexagon, sum of external angles is always 360 degree. Whether it is a triangle or quadrilateral or pentagon or hexagon, sum of three angles is always 180 degree. Sum of three angles, external angle is always 360 degree. Okay. Okay. So today we'll stop here. So there are more to show. So in my next video, I'll show you some more important questions which are common in exam. Actually, I always select questions from exam so that it will become easier to you. All right. Okay, then for today, let me stop. Thank you.